What if we swapped our sun with another star? Last time we threw Earth into the fires of Rigel, froze it under Proxima Centauri, and watched it get swallowed whole by Betelgeuse. Yeah, things got messy, but the universe is full of even stranger stars. Colder, hotter, smaller, and way more dangerous. So in part 2 we're going deeper. What happens if we replace the sun with a white dwarf, or a neutron star, or one of the biggest stars ever discovered? Would Earth survive? Would it even exist? Let's find out. Let's start small, deceptively small. Sirius B is a white dwarf, the dense burnt-out core of a once full-size star. It has the same mass as our sun, but crammed into a space no bigger than Earth. To put that into perspective, a single teaspoon of Sirius B would weigh 15 tons. That's heavier than an elephant, made of star stuff. It's still blazing hot, 25,000 degrees Celsius. But don't let that fool you. Because it's so tiny, it only gives off 2.5% of the sun's light. If Sirius B replaced our sun, Earth would be plunged into darkness. From space, we'd see a tiny blue-white dot. From the surface, barely anything at all. The sky would turn black, stars would dominate even in the daytime, and the familiar warmth of the sun would vanish in an instant. Temperatures would plummet to negative 150 degrees Celsius or worse. The oceans would freeze solid. The atmosphere, gone. Earth would become a silent frozen tomb drifting around a cosmic cinder. And that's if we stayed in orbit. Technically, gravity wouldn't change much. Same mass, same year. But the sunlight would vanish. Life extinct. Now let's go colder. WISE J0855-0714 is the coldest brown dwarf we've ever found. It's not really a star, it's a failed one. Too small to ignite, too big to be a planet. Its surface temperature is just negative 50 degrees Celsius. That's colder than the North Pole, and it doesn't emit visible light, only a faint infrared glow. Earth would be plunged into total darkness if we swapped the sun with this icy dud. No sunrise, no warmth, just eternal night, and the gravity practically non-existent. With only 3 to 10 times Jupiter's mass, this brown dwarf is less than 1% the mass of our sun. That means Earth and every other planet would just drift off into space. Over time, the solar system would unravel. Planets would slowly spiral outward, their orbits collapsing into the vastness of the galaxy. So yeah, no light, no heat, no gravity, just a frozen, lonely rock in the void. Let's swing the pendulum hard in the other direction. Say hello to the Crab Pulsar, a neutron star formed in a supernova explosion. It's the size of a city, with 1.4 times the mass of the sun, and it spins 33 times per second. This thing isn't blast out intense beams of radiation, mostly X-rays and gamma rays, with surface temperatures over 1,000,000 degrees Celsius. If we replaced our sun with this little nightmare, Earth would be hit by deadly radiation pulses every second. The ozone layer obliterated, the atmosphere stripped away, and the surface fried. Your phone would fry, your skin would burn, electronics would fail. The sky would flicker with auroras that never stop, until there's no one left to see them. And despite all that energy, we would still freeze, because pulsars don't emit much visible light or warmth, just radiation strong enough to sterilize an entire planet. In short, frozen, airless, irradiated death. Alright, let's try something a little less horrifying. Chion A is a subgiant, just 1.5 times the mass of the sun, and about 7 times more luminous. If it replaced our sun, Earth would suddenly be way too close for comfort. At 1 AU, we'd receive 7 times more sunlight. That's enough to send global temperatures soaring to 500 degrees Celsius. The oceans would boil. The atmosphere would become a thick, choking stew of steam and CO2. Earth would become a pressure-cooked version of Venus. We'd have to move the planet way out to survive, somewhere around the asteroid belt, and even then we'd be dealing with harsh UV radiation in shorter years. Earth would be caught in a new rhythm, one that scorches instead of soothes. But if we stayed where we are, we'd be toast in days. Now things get massive. Deneb is a blue-white supergiant, one of the most luminous stars in the night sky. It's 19 times the mass of the sun and 203 times the size. If you dropped it into the center of our solar system, its surface would nearly reach Earth's orbit. So yeah, We'd either be skimming the star's surface or inside it, which means instant death. Earth would be vaporized, its atoms drifting through a star's outer layers. Even if we were just beyond Deneb's surface, we'd still be cooked by 200,000 times more light than we get from the sun. Forget sunburn, this is atom burn. Our planet would glow like a firefly for all of 2 seconds before disintegrating. No atmosphere, no oceans, just molten rock glowing in the hellfire. Now let's take it even further with a true monster. Stevenson 218 is a red hypergiant and is currently considered the largest star ever observed. Although this is still being disputed, for now, let's pretend it is. The radius 2,150 times the size of our sun. The thing is so big its outer layers would engulf Saturn, and despite its monstrous size, it's relatively cool, around 3,200 degrees Celsius. But don't be fooled. It shines over 400,000 times brighter than the sun. That means if you replace the sun with Stevenson 218, Earth would just burn. It'd be inside the star. We'd be instantly vaporized, our orbit reduced to a meaningless swirl of plasma within the star's envelope. Even planets as far out as Jupiter would feel the heat, their atmospheres stripped away by intense radiation. And because Stevenson 218 is so massive and unstable, its gravitational pull and stellar winds would wreak havoc across the entire solar system. We wouldn't just be dead, we would be dispersed. And just when you think it can't get more extreme, let's talk Scotty. Once considered the largest star in the universe, Scotty was dethroned after newer measurements revised its size. But don't relax, it's still an absolute beast. Even with its updated radius, roughly 900 times the size of the sun, it would still engulf the orbit of Mars. At 3,550 degrees Celsius, it's slightly hotter than Stevenson 218, but still way cooler than our sun. If Scotty took the sun's place, Earth would again find itself deep inside the star's atmosphere, cooked, crushed, and disassembled. The outer layers would smother our planet in superheated gas, erase any traces of oceans, continents, or atmosphere. And even if Earth somehow stayed just outside the star, the intense radiation, over 100,000 times what we're used to, would sterilize the surface in seconds. In short, another oversized death trap. But wait, there's bigger. RSGC1-F01 is a red hypergiant with a radius about 1,500 times that of the sun, large enough to swallow everything up to Jupiter. But this thing in place of the sun, the Earth wouldn't just be close to it, we'd be inside it. The temperature inside its outer layers is around 3,500 degrees Celsius, more than enough to melt rock and vaporize oceans. That's exactly what would happen. Earth wouldn't orbit anymore, we'd dissolve into glowing gas, absorbed by the star. Even our orbit would no longer make sense. Gravity, friction, stellar winds, they'd all conspire to tear us apart. Our entire planet would vanish in minutes. Ready for the final boss? R136A1 is one of the most massive and luminous stars ever found. A 315 solar mass monster shining with 9 million times the sun's brightness. It burns at 53,000 degrees Celsius and emits energy like a cosmic blowtorch on steroids. If this thing replaced our sun, Earth would be gone in less than a day. The heat would hit 16,000 degrees Celsius, enough to vaporize rock. Our planet would become plasma before the day was over, and the rest of the solar system obliterated within a week. Planets would peel apart like onions, their layers stripped by intense radiation and wind. The solar system would become a field of glowing debris. Oh, and R136A1 will go supernova soon. So if somehow anything survived, it wouldn't be for long. So what did we learn? Swap in a dead star, you get darkness, radiation, and a frozen death world. Go too big, you get boiled, vaporized, or completely swallowed whole. Try a nice middle ground. Still way too much light and heat. Turns out our sun isn't just fine, it's perfect. Not too hot, not too cold, not too big or small. Just right. The literal Goldilocks star. So the next time you complain about sunburn, remember, it could be worse. A lot worse. Thanks for watching. If you enjoyed this cosmic chaos, hit that like button. It helps way more than you think. Got a mind-blowing what if you want us to cover? Drop it in the comments. And if you haven't already, subscribe for more wild journeys through space, science, and the end of the world. Catch you in the next one. Stay curious.